So this is a new unit, Unit 5 and Lesson 1. In your textbook, instead of calling it Unit 5, they will call it Chapter 5. And the topic of this lesson will be solving systems of linear equations by graphing. So take this moment to please write name, date, and period on this paper. And you should have this paper in front of you. If not, you should get it from the bin or get one from the teacher. All right, so we spent most of Chapter 4 graphing linear equations so that we could actually use the skill and that knowledge to do more advanced questions. And more advanced questions will be in Chapter 5. Chapter 5 is an example of when you might need to graph a linear equation. There are a couple things about systems of linear equations, which is what we'll be working with in Chapter 5. In Chapter 4, we only worked with linear equations, just linear equation. But Chapter 5 is called a systems of linear equation. There are 4 sections in Chapter 5. The first one we're going to start with is graphing. And basically, we're learning 1, 2, 3, and possibly even 4, about 3 different ways to solve systems of linear equation. The first one we're going to do is by graphing. So let's start taking some notes. Okay, so I talked to you about systems of linear equations. So here, let's talk about what it is about. A system of linear equation is a set of 2 or more linear equations. For example, this one is a system of linear equations because you have two linear equations. Or you could have 3 linear equations, and this is called a system of linear equations. A note is that a system of linear equation is also called just linear system. This will be a shorter way of calling it. Now, we have looked at different equations before. And it's been a while now, but we have been looking at equations for the long time, and I think the first type of equations we've seen were some things like this. 3x is equal to 6. These are the regular linear equations that have only one variable, and we practiced solving them before. To solve this, you would just divide both sides by 3, and your answer will be just x equals 2. However, now that we have equations that look like this or this, where you have both x and y, and here you have both x and y, you have 2 variables. We can say that the value of the variable is the solution because there are 2 variables. So a solution of a system of linear equation is, and we're going to use it as order pair. So when you're solving for systems of linear equations, your answer should be, your solution should be a order pair. And what I mean by order pairs are these parentheses with x, comma, y. So basically we are looking for a coordinate point. That's the solution. And we will see in Chapter 5 what that order pair looks like. And again, there are many ways to solve systems of linear equations, like I mentioned before. But in this lesson 5.1, we will learn how to solve by graphing, and that's the first method. Now, students, you'll be graphing, you'll be dealing with a lot of lines. On a coordinate plane, you'll be drawing graphs. And whenever you have lines, you can possibly have lines intersecting, and that will be your solution for this lesson. And we're going to call this the point of intersection. Your solution will be the point of intersection. Now in this picture, I only have two graphs here, but you could actually possibly have lots of different graphs intersecting. For example, if you have one and you have maybe more than two lines intersecting, that's two, and if you draw one more, you have three lines intersecting, right? That's possible. So let's move on to our first example. Example number 1, solving a system of linear equations by graphing. You have two equations, and like I said, you will be solving these by graphing. And if you graph, what would it look like? You would have two lines intersecting, and the point where they intersect will be your solution. So first, what we need to do is we need to graph them. And in order to graph, back from chapter 4, we need to find the slope and the intercepts. The y-intercept, right? We use the slope-intercept form. Now, if you look at the first one, the slope is 2, and you can write that as 2 over 1, because you always want to write the slope as a fraction. That means you're going to go up 2 and right 1. Then the y-intercept is b, and the y-intercept for this equation is 5. And then the next one, the slope is -4, but you put a 1 under to make it a fraction, so -1 over 4, which means it will be down 4 and right 1. And the y-intercept for this will be, as shown here, -1. And we're just going to graph them. Now, if you're not sure how we got these values, you must come see me for help, because I am not going to refreshing that in your memory at this point. I just am expecting that you already know this. But again, if you're not sure how I got these, and if you're not sure how to graph them, then you need to come see me. Okay, so let's graph. I'm actually going to use different color. I'm going to graph this one in red, and I'm going to graph the second one in blue, so that it'll be easier for you to see. Now we will always start by labeling the axes, so let's label them. This will be the y-axis, and this is the x-axis. Now if you want to, then you can also put numbers on this graph. So if you want to, please pause this video and put numbers on these grids, like 0, 1, 2, 3, like I am doing. I'm not going to number all of them, but you can do them all if you want to. And these are positive, and then these should be negative, the left side and the bottom. Okay, so let's start graphing. So the red one, the y-intercept is at 5, so on the x-axis you're going to go up 5. 0, 1, 2, 3, 4, 5. That will be our y-intercept. And then the direction is up to right 1. And we can go backwards down to left 1, down to left 1. And use your ruler to graph them. Please don't forget to draw the two arrows and label the equation. Now the blue one, the y-intercept, b is -1. So on the y-axis, you're going to go down 1. So 0, 1, -1, right there. And then the direction is down 4, right 1. 1, 2, 3, 4, right 1. You can go backwards, up 4, and left 1. And you probably realized it already, but you see the points overlapping. If you draw the lines, you will see the blue line with the equation labeled. Now, if you're intersecting the lines, then your line should be straight so that you get the most accurate answer. If they're not straight, you're possibly gonna make a mistake. So we circle the point of intersection. Point of intersection is where the two lines intersect, and for our problem, it'll be here. I'm going to shade it in black. And that is our answer. The answer is the coordinate point where the two lines intersect, and this is a point of intersection. Point of. Remember, we wrote that in our notes. It's the order pair where they intersect, and then the order pair for this will be -1, 3, because it's always x, y, and the x value is at -1, and the y value is at 3. So it'll be -1, 3, and our solution will be -1, 3. That is our answer. Now, you can check this because by plugging this into each equation and make sure that it works. Remember, it's got to work in both equations to be a solution. So I'm just going to verbally check it. So we know that x is -1 and y is 3, so let's plug it back into the equation. If you put -1 in the x and it's 2 times -1 plus 5 is 3, and y is 3, so it works. And then here, -4 times -1 is 4, and -1 is 3, so it works. And again, if it does not work in both equations, then it's not the solution. For ours, this is a work. And I will show you how you can check your answers later on, but again, you should try it on your own, okay? So if you plug them in, here's how you can show your work in writing. I plugged it into the first equation, and I plugged it into the second equation, and both of them are correct. So -1, 3 is the solution. For the next part is on your own. It says solve the system of linear equations by graphing. For this one, you're going to pause the video and try this on your own. Graph these equations on the line. Make sure you graph them by following all the criteria of graphing, and come back to check your answer. Okay? After you've done that, after you checked your answer, if there's any mistake, please correct them. And that will be the end of video lesson number 1. So after you check your answer, please move on to video lesson 2. Thank you. And here is the answer. I graphed the first equation in orange, the second equation in pink. Remember, this x, there's an invisible 1, so the slope is 1 or 1 over 1. And the second one will be slope -1 or -1 over 1. If you graph them, the point of intersection will be at 2, 1. And I checked my answer by plugging in the value into each equation. I plugged in 2, 1 into the first equation. The left side is equal to right side, so that one's correct. And then I plugged it into the second equation, and that one also worked. So this is a solution to both equations.